Hello all, this is Mr. G, and in this video we're doing a review of congruent isosceles triangles, equilateral triangles, CPCTC, and proofs. Let's not waste any time, let's jump right in. So let's take a look at numbers 1 through 4. So they're giving us a congruent statement at the top. It says SFJET is congruent to IWNLO, and we're going to use that to complete each congruent statement, essentially to fill in the blanks. So number 1, it says angle E is congruent to something. Well, E is right there. So that matches up with L, so that would be congruent to angle L. Next up, that's the ugliest L I've ever seen. Whatever. Next up is angle W is congruent to something. Angle W, or W rather, is right there, so that corresponds to F, so it would be congruent to angle F. Now we've got segment NL, which, let's see, NL is right there. That corresponds to J and E. They're in the same position, so it's congruent to segment JE. And last on this slide, we've got segment TS is congruent to something. So T and S are sort of split. But okay, we do the same thing over here. O and I. So segment O, I. Let's check our answers before we move on. What's going on there? There we go. So L, F, J, E, O, I. Excellent. Okay. Now we're going to find all variables. Looking at number 5. Now, whenever we're dealing with these type of triangle problems, I always like to think, okay, what do I notice about the triangles? And this triangle, immediately I notice those two congruent markings. So essentially, there are two congruent angles making this an isosceles triangle. And if there's two congruent angles, there's also two congruent sides. Now, there's a few different ways to do these problems. I'm going to show you 2 ways to do it. The way I like to do it is remembering that the angles that are congruent are the base angles. So this angle and that angle are base angles, which means that this side is the base. So I'm going to write base right there. Now what's special about the base, besides just that it touches the two congruent angles, it touches the base angles, is that the base in an isosceles triangle is the non-congruent side. It's the side that's not the same as the other two. So that means these two sides are going to be the legs. They'll be the congruent sides, which means, okay, x has got to equal 4. We can put that in right there. And check our answer. X equals 4 feet. Excellent. So this is one way to do it. The other way to do it without finding the base is to remember that the two congruent sides are always opposite from the two congruent angles. So if we start this congruent angle and go opposite the shape, we hit x. And if we start this congruent angle and go across the shape, we hit 4. That means 4 and x are the congruent sides. So either way, we still get the same answer. Use the way that makes most sense to you. Take a look at number 6, same directions, finding all variables. So we got to find A and B. Few different places we could start here. I would probably start with the triangles, because looking at this triangle and this triangle, I immediately see that they are both equilateral. Now, we have no idea how long the sides are. We know the sides are all going to be equal, but we don't know if these sides are like 2 inches or 2 miles. We've got no idea. But we know something about the angles. Since all the sides are the same, all the angles must be the same as well. And we can even go a step further. Since this is an equilateral triangle, hopefully we have memorized that all these angles will always be 60. And if you ever forget that, you can always do the total of the angles in a triangle, which is 180. And since there are 3 congruent angles, we just divide that by 3, and that gives us 60. That's another way, in case you ever forget whether it's 60 or 50 or 70, just do 180 divided by 3. And that actually gave us one of our answers. B is 60 degrees. Oh, we don't need that work there anymore. So let's fill in 60 here as well. 60, 60, and 60. Okay, still trying to find A. We haven't done anything with this shape yet, so let's work in that shape. I see 90 degrees, and I see 4 congruent sides. 1, 2, 3, 4. Well, all the sides are congruent, and we've got 90 degrees. That means the other ones are going to be 90 as well. So we can put 90 degrees at where essentially it's a square. Now we've got all the angles around A, but we're sort of missing A still. But all these angles make a full rotation. They make a full 360 degrees. So what we can do is add up the angles we know in that full rotation, subtract them from 360, and we'll be left with the one part that's missing. We'll be left with A. So we do 90 degrees plus 60, adding up. Let me color code this. So we're adding this 60, and this 90, adding up those 3 angles, and that comes out to 150, 210, if I'm doing that correctly. I'm going to double check myself. I don't feel like screwing this up. Please turn on. So 90 plus 60 plus 60. Good, 210. Then we take that away from 360. 360 minus 210, and that's 150 if I'm doing that correctly in my head. So then A would be 150, and we can check the answer right here. A is 150 and B is 60. Excellent. Take a look at number 7. Again, I look at this triangle and I think, okay, what type of triangle, not just what type of triangle, but what do we notice about the triangle? What clues are they giving us? And here, the clue that jumps out to me right away, besides the number they're giving us, besides the 45 degrees, are these markings. This triangle has two congruent sides, meaning it's isosceles. And if there's two congruent sides, there's two congruent angles. All we have to do is find the base, and then we can see that the base angles will be congruent, or we can identify which angles are the base angles. That's a better way to say it. Looking here, remember the base is the non-congruent side. So if this side and that side are congruent, the base is the other side. And if that's the base, then the base angles are the two angles that touch it. So that means X and Y. And that's what we're looking for here, X and Y. Since those two angles are congruent, well, it's still a triangle, so we know that the three angles will add up to 180. So normally, in a triangle problem, we sort of add up the two angles we have and subtract 180. But we only have one angle here. We only have 45 degrees. So we can subtract that, and that gives us 135, if I'm not mistaken. 135. Now, 135 isn't X or Y. It's X and Y together. Because all we did, we subtracted just this one angle, that 145 degrees, from 180. So the remaining 135 degrees is for both the base angles, X and Y, together. And since X and Y are congruent, we can take that 135 and cut it in half. We can divide by 2. We can only divide if our two parts are congruent, if the two parts are equal, and they are here. We divide that by 2, that becomes 6, carry the 1, 7.5, so 67.5. And that's actually going to be for both of them, 67.5 degrees. We could put it in the diagram if we want, but we don't need to. Check the answer, 67.5. Excellent. All right, another one where we're finding variables, number 8. Here we only have to find one. We're just looking for H. I see two triangles, though. We could start in either one. I guess we'll start in the equilateral one, this one. 3 congruent sides. I actually kind of prefer to start with an equilateral triangle because immediately we know what the angles are, not the sides. So don't put the 60 here. The side is not 60. The angles are 60 degrees. We can put that into our diagram. And now we have to, we've got to find H. So we've got to work in this big triangle somehow. And we actually have an angle in this big triangle now, because this big angle, we can add 60 and 11 together, and that will be, 60 and 11, that's just 71. So that means this big angle right there is 71 degrees. Now again, if we're focused on this big triangle, hopefully we see that there are two congruent sides, right there and right there, meaning it's isosceles. And if there's two congruent sides, there's also two congruent angles. To find them, we just have to find the base. We have to find the non-congruent side. And in this big triangle, the non-congruent side is right here. So I'm going to write base down there just to help me remember that that's the base. Which means the two congruent angles will be, let me do this in a different color, this angle right here and this angle right here. So this is also 71 degrees. Now to find H, we've got two angles in this triangle. We've got 71 and 71. Which means we can just add them together, 71 and 71, that's 142. And just like any triangle angle problem, take that away from the total of 180. And that's going to be 38, if I'm doing that correctly in my head. 38 degrees, I think that's correct. Check the answer, and we're good. Excellent. Okay, all right, change of directions. Could you prove that the two triangles are congruent, why or why not? So here's where we have to look for side, side angle, side, that sort of stuff. And in number 9, let's see what's sort of marked already for us. I see a pair of congruent sides, and I see a pair of congruent angles. So that's 2 pairs, but we always need 3. We always need 3. So at the moment, this is none of the information, unless there's something we're allowed to add in. And hopefully, you see that X right here. And anytime you see an X, you should think, oh, we've got vertical angles. meaning this angle and that angle are also congruent. So we've got another pair of angles. Then we just focus on one of our triangles to figure out what the pattern is. And here I see two angles with the side in the middle, and we should see the same thing over here. If we focus on that triangle, two angles with the side in the middle, that means this is angle, side, angle, which works. So it's yes by angle, side, angle. Check the answer. Yes, angle, side, angle. Good, good, good. Number 10, same directions. Let's see what they're giving us. I see a pair of congruent sides right there. I see another pair of congruent sides there. There's no X for vertical angles, but the triangles are sharing that side. Anytime the triangles are sharing a side, we can use the reflexive property, or really when they're sharing a side or an angle. Usually they're sharing a side, not always though. So here they're sharing that side, meaning we have essentially segment BD in one triangle is congruent to segment BD in the other triangle. So that's another pair of sides, even though it's just one side. That one segment is in both triangles. Now we just take a look at what we have. And I mean, this one's not that hard to see. It's just three sides, which is side, side, side. So it's yes by side, 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 because that is one of our patterns that works. And we check our answer, and we got it. Number 11, same directions. Let's see what they give us. I see a pair of angles that have the same number of markings. I see a pair of sides that have the same number of markings, and a pair of angles. So we're actually given three pairs. So we don't have to look for vertical angles or the reflexive property or anything. We just look at our three pairs, focus on one of the triangles. It doesn't matter which one. And here I see two angles with the side that's not in between them. This side right there is not in between the two angles. This side are in between the two angles. So this is not angle, side, angle. This is angle, angle, side. Let's make sure it's the same in the other one. Focus on this triangle. Angle, angle, side. Yep, the side's not in between the two angles. And that's another one of our patterns that works. So it's yes by angle, angle, side. Number 12. Same direction, so we approach this the same way. I see a pair of sides. I see a pair of angles, and that's two pairs, but we know we always need three. But they're sharing a side. They're sharing this side, segment UE, so we can add in the reflexive property. A pair of sides right there. All right, now let's take a look. Focus on this triangle. Doesn't matter which triangle you pick. I'm just picking that one. And I see two sides. Then the question is the angle in between them or not? And it looks like not. Let me do this in a different color. These are the two sides that are marked. The included angle, the angle in between them, would be right there. That's not where the angle's marked. So this is, and I've got to be careful I write this in the correct order, it's going to be side, side, angle. Now this is one of our patterns that does not work. So it's going to be no by side, side, angle. I guess there's one exception for side, side angle. Side, side angle only works if this angle we know is 90 degrees. Then we would call it HL. But this angle right there in both of the triangles, we have no idea if it's 90 or not. So, we cannot prove them. We cannot prove that the triangles are congruent. The triangles might be congruent, but we can't prove it based off the information we see. Number 13, same directions. Scroll down slightly. Okay. What do we have here? We got a pair of angles, another pair of angles with the same number of markings, and another pair of angles. So we don't need to look for anything extra here. We've got three pairs. Oh, and it's just angle, angle, angle. Now, angle, angle, angle does not work for congruence. We cannot prove that two triangles are congruent if they have three pairs of congruent angles. So this one's no by angle, angle, angle. These two triangles would be similar, but not congruent. Number 14, okay. Pair of sides, pair of sides, pair of angles. So we've got three pairs. Don't have to look for vertical angles or anything like that. Let's just focus on this triangle. I see two sides, and this time the angle is included, is in between. And it's the same in this one, I believe. Two sides, and the angle's in between them. The angle's included. So it's side, angle, side. That is one of our congruence patterns. So we say yes by side, angle, side. Number 15. All right, same directions, but this diagram has me slightly concerned because in this diagram, I see 1, 2, 3, 4, 5 different triangles. And if you don't believe me, let me erase that. 1, 2, 3, 4, and 5. So there's 5 different triangles here, which means we have to pay close attention to the directions to figure out which two triangles they want us to focus on. So it's RQS, and STR. STR. Now you don't have to do this, but I like to take our overlapping triangles and rewrite them, sort of separate them. That makes these problems easier for me. So I'm going to do the blue one first. So that's R, Q, and S, just so it's easier to follow. Now, what markings can we bring over in the blue triangle? I see a side marking right there and an angle marking on R. Now, angle S, we do not bring over this angle marking because that angle marking does not perfectly fit the blue triangle. It's too big. It goes like it starts out in the blue triangle, but then it keeps on going past it. So we do not include that one. So that's all we have for the blue triangle. Let's copy the green over here. Yeah, the drawing's not perfect, but whatever. So it's R, T, and S. What markings do we see? On TS, I see a side marking, and on the green S, I see an angle marking. Again, we're not going to bring this angle marking over for the green triangle because it's too big. It does not fit. What do we have so far? We'll do this in black. I see a pair of sides, and I see a pair of angles. That's not enough. We need one more pair. Otherwise, this is a not enough information problem. If we look back at our original diagram, we do see vertical angles. There's an X there, but I don't think that's going to be helpful because like this angle, those two angles are not in either the blue or the green. They're not like either, they're not any of these corners, R, Q, or S, R, T, or S. So even though we have vertical angles, that's not going to be helpful here. What we need to use is the reflexive property because these two triangles are sharing that side. Both the green and blue triangles have RS in it, so we can say RS is congruent to itself, giving us another pair of congruent sides, making this side angle side, which works. So we say yes by side angle side. Check the answer. Excellent. Very good. All right, change in directions. What additional information would you need to prove the triangles are congruent by angle angle side? Let's take a look at what they're giving us first off. We've got a pair of sides that are congruent, a pair of angles that are marked congruent. Now, at this point, we have no more additional information that we're allowed to put in, which is why they're saying, okay, what extra information would we need? We cannot say these two triangles are congruent, but what extra information would make these work by angle side? Let's see what we're missing. I see a pair of sides and a pair of angles, which means we're missing a pair of angles. We need two pairs of angles for angle side. In this triangle, triangle IMC, what angle would make it angle side? We want the side not in between the angles, so that would have to be right here. So we would say angle C would need to be congruent. Would need to be congruent. I'll just use the symbol to save time. Congruent to, and that would have to match up to angle Y. That would make it angle side. Two angles with the side not in between it. So angle Y. And then we can check the answer. Angle C and angle Y would need to be congruent. Okay, I didn't say it in exactly the same order, but essentially it means the same thing. Good, good, good. 17. Same directions, but now we're using side, side, side. Let's look at what we're given. We're given a pair of sides. Oh, and I see the reflexive property that we would be allowed to add in. So we have two pairs of congruent sides now. And for side, 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 well, obviously we're missing the third pair of sides. That's what we need to add in. So in this triangle, let me sort of highlight it. In this triangle, the only side that's remaining is right there. So that's segment JK. Segment JK would need to be congruent. Would need to be congruent to, let's see, in the other one. So we don't need this anymore. Now we're focusing on this one. Side, side, side. The only missing side is segment LN. Check the answer. Segment JK and segment LN would need to be congruent. Good, good, good. Number 18. Still looking for additional information here. And now we're using side, angle, side. Let's mark what they've given us. Pair of sides, another pair of sides, which means for side, angle, side, we're missing the angle. We need to find a, how do I want to say this? We would have to add in, we would have to see another pair of congruent angles to use side, angle, side, because right now we cannot use side, angle, side. In this triangle, that's the one I'm focused on. The angle that's in between the two sides would be angle I. So this angle, which means we would say angle I would need to be congruent. Would need to be congruent to, let's check the other one. In this triangle, the angle that's in between the sides would be angle U. So we would say need to be congruent to angle U. Check the answer. It didn't work nicely, but whatever. Angle I and angle U would need to be congruent. Very good. Okay, same directions, but now it's saying angle, side angle. Again, let's look at what they're giving us. A pair of sides, and that's it. But I see something we can add in. We see that X, which means we can add in this, that pair of vertical angles. So we got a pair of sides, a pair of angles. To use angle, side, angle, we're missing a pair of angles. Missing a pair of angles. Let me see. In this triangle, angle, side, angle, we want the side to be in between the two angles. The angle that would do that is angle G, which means angle G would need to be congruent to, let's check the other triangle now. Erase that. In this triangle, to use angle, side, angle, the angle that would be in between them, or the angle that would make the side in between the two angles, I guess is the way I wanted to say that, is angle F, because then it would be angle, side, angle. Two angles with the side in between them. So angle F. Check the answer. Oh, doing that again, whatever. Angle G and angle F would need to be congruent. Good. All right, finally we're on the proofs. So here we're going to have to do a two-column proof. Actually, before I write the line for the two-column proof, I see two triangles that are overlapping. So let's separate those triangles. Now, some of you might be good enough where you don't have to separate the triangles, but it really keeps me from making a mistake. So let's focus on this. So HIG is our first one. I'll tell you what, I'll just separate that one right now. So here's HI and G, HIG. What markings are they giving us we can bring over in that blue triangle? Well, we've got a mark on angle H, and I see this marking on GI. And that's it. Don't fall for the trap of bringing this over. That segment is, or excuse me, that segment notch, that dash, is not for GH. It's only for GK. It's not on GH, it's only on GK. So don't fall for that mistake. And that's all we see for the blue one. Next up is MKG, which I'm going to copy over here. So it's G up there, K, and M. What markings can we bring over for the green? I see an angle marking on M. And, okay, we've got a couple side markings, but we've got to be careful to only bring over the one that applies for the green, which is right there on segment KG. And that's it. Let's start our proof. So we'll draw the line for the proof. Let's see if we can fit in here. Let's start with what they're giving us. I like to start with the angles. So we got a pair of angles here. That's angle H is congruent to angle M, and that's given. Next up, I see a pair of congruent sides that were given to us. So we can say segment GI is congruent to segment GK. Given. And now we're all out of given, so we need to look for something we can add in. And what we want to add in here is using the reflexive property, because both the green and the blue triangles share angle G. So we can add, I would need two angle markings there, and we can put that on the blue and the green, giving us another pair of congruent angles. So we can just say angle G. Angle G is congruent to itself, to angle G, by the reflexive property. Let's get my face out of the way. Reflexive property. Reflexive property. Now that we have our three pairs of congruent parts, it's time for the triangles. So we can say triangle. I'm going to steal this right from the directions, right from there. Triangle HIG is congruent to triangle, that's the worst triangle I've ever drawn, triangle MKG. It's a pretty bad M too. Whatever. Now for the most important part of the proof. Is it side, 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 angle, side? What are we looking at? In this triangle, I see two angles with a side not in between them. That would be angle, angle, side. Do we see the same thing here? Yes. Two angles with the side not in between them. So we can say by angle, angle, side. I'm going to double check that one more time before I end this one. Angle, angle, side, angle, angle, side. Excellent. And this proof is finished. Next one. Again, we've got two overlapping triangles. So let's start with TWX, which is right here. T, W, and X. Let's draw the blue right here. T, W, and X. What markings can we bring over there? I see an angle marking on T we can bring over. Now here I see something that trips students up. On this segment TX, I see markings going all the way across. I see 2 markings on that part and 1 marking on that part. So that's what we're going to copy over. We're going to copy over 2 sort of closer to T and 1 closer to the X. Now some of you might be thinking, well, wait a minute. This is kind of confusing. Didn't Mr. G on this last example say we don't bring this one over for both triangles? Like that one didn't come over on the blue triangle for GH. And that was because this segment of GH had a marking, but this segment had nothing. So because of this blank side, we really can't bring any markings over. But if we see markings all the way across, okay, so we got 2 there and 1 there, then we can bring them over. It's completely filled with markings. I guess you could think of it that way. Anything else in the blue? No. Let's move on to the next one, which is ZYN. ZYN. I think I can fit this here. ZYN. And drawings aren't perfect, but whatever. Where's Y? Y is right there, and N is on the right side. Okay. What markings can I bring over? I see an angle marking on Z. And then on this segment, I see that weird 2 then 1 thing. We've got 2 and then 1, so that's what we copy over. So undo that because we don't want this board work to be worse than it already is. So we've got 2 closer to Z and 1 closer to N. All right, now that's not enough information as it is. I only see 2 pairs, but let's start the proof. Let's start the proof. So let's start with the angle. So angle T is congruent to angle Z. Pair of congruent angles right there. And it's given to us. Those markings were there waiting for us to see them. Next up, I see a pair of congruent sides. We can say segment TX is congruent to segment ZN. And that's given because this side and this side have the same markings on it. So we can say that's given to us. Now, eventually we're in like college or something like that. We're going to need to have some extra steps in there showing that there's more parts congruent. But we don't need to worry about that right now. We are right now in our mathematical careers. That step is good enough. Eventually, once you get to like geometry in college, you can add on to that. Anyways, I'm getting distracted. What are we talking about? Okay, so we've got our givens. Now we need our third step. Now, some of you might be tempted to use the reflexive property because we see sort of that side being shared by the blue and the green, but that segment XN is not in either of our triangles. XN is not a side of a triangle, so we don't want to use the reflexive property here. What we need to do is focus on this triangle, that middle triangle, which has 2 congruent sides, right there and right there, meaning it's isosceles. Now, if there's 2 congruent sides, there's also 2 congruent angles, the base angles. So we have to find the base. The base is the non-congruent side, which is XN, that segment. So the base angles are the ones that are touching it, which would be right here, angle X, and that angle N. So I can add in angle X and angle N, those 2 markings. We're going to have to be more careful when we name it because there's actually 2 angles here that are angle X. So to be clear about which one we're talking about, I'm going to say angle, we could name this a few different ways. I'm going to say TXN, angle TXN, using 3 letters. So essentially just following this, TX and, TXW, TXN, it's the same thing, whatever, is congruent to angle, and what was the other one? ZNX. ZNX. And again, if you wanted to call that Z and Y, that would work just the same. Or, I mean, you could also call it VNX or VNY. You've got lots of options here, but you can't use just one letter. You can't just say angle N because there's too many angle N's. Let me do this let me see if this color shows up. There's this angle N, and there's also that obtuse angle N. So we have to be more specific when we name it. Okay, let's move that out of there. Oh, I didn't even give my reason yet. Why are those 2 angles congruent? Because they're base angles in an isosceles triangle. Base angles of an isosceles triangle. Isosceles, I'm always worried I'm going to misspell that. I think that's correct. An isosceles triangle. Now that we have our 3 pairs, we go to our congruent statement. Steal it from the direction, so we can say triangle TWX. TWX is congruent to Triangle, what was the other one? ZYN. ZYN. And now we need our reasoning. So if we look here, oh, I forgot to put the A's for that pair of angles. You don't need to do that, but it helps me. I see angle, side, angle right here. So angle, side, angle, the sides in between them, and the same thing on the other one. I'll do this in red so it stands out. Angle, side, angle. So that's what we write, angle, side, angle. Angle, side, angle. I'm going to double check that one more time because I really don't want to mess up the last step here. Angle, side, angle, angle, side, angle. Very good. All right, 2 more to go. All right, oh, this is a typo. I'm not going to have time to go back and edit this. We're just going to add that in now. We're going to write a quasi-proof that triangle HFN is congruent to triangle JFM. So we're trying to get in this triangle to that triangle. Now remember, when we write a quasi-proof, this is a term that I use to say, okay, this proof is going to be so long that you don't need to write the given. You just have to write what we're adding in. Now in triangle HFN, what could we add in there? I mean, we've got these two sides that are given, so we can mark them if we wanted to, pair of congruent sides. But that's not going to be enough. Fortunately, we see the reflexive property right there. So we can add in 3. So we can say segment FM is congruent to segment FM. And that is by the reflexive property. Reflexive, I'm just going to abbreviate property to save some time and space. So that's another pair of congruent sides. All right, so that's pretty good. So that means we've got 2 congruent pairs in the 2 triangles we're working in, HFN and JFN. But I see nothing else we can add in there. So we've got to go looking elsewhere. Fortunately, they give us 2 other triangles down here that we can use, triangle HKN and JLM, those 2 triangles. And they give us a pair of congruent sides. Actually, let's do this in green since we're in 2 other triangles. We got a pair of congruent sides and a pair of congruent angles. And then we have to see that we have an X right here for vertical angles. So that's going to be our 3rd pair for those triangles. Now that wasn't given, those vertical angles, so that has to be included in our quasi-proof. So we're going to say angle, what's that first one? HMK, angle HMK is congruent to angle JML, angle JML, and that was by vertical angles. Vertical angles. I'm just using the angle symbol there. All right, now we can show those 2 triangles are congruent. So we can say triangle, what was it? HKM. HKM is congruent to, now I got to name this one in the same way. So if I went HKM, then it needs to be in the same order. So JLM would do it. JLM, and that was by angle, angle, side. 2 angles with a side not included. Now, those were not the 2 triangles we wanted to prove congruent, but we can use this now. Since this triangle is congruent to this triangle, we can add in almost any congruence markings we want because all the corresponding sides and corresponding angles are now congruent. The ones I would pick are this side, 1, 2, 3, 4, and this side, 1, 2, 3, 4, because those sides are also in the 2 triangles we're trying to get to, HFM and JFM. The line of the proof would be segment HM is congruent to segment JM by corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. And now we have our 3 pairs in the original triangles we were trying to get to. Triangle HFM is now congruent to triangle JFM. And if we look back here, I'll do this in red. We've got side, 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 and side, side, side. So that's what we write, by side, side, side. I'm not going to put the box at the end of it because this was not a full proof. It was just a quasi-proof. Now we move on to number 22. All right, triangle ABC is equilateral, triangle BCD is isosceles, and the 2 shapes overlap. If, forgot my segment symbol, if segment BD is congruent to segment CD, and the measure of angle BDC is 110, what is the measure of angle ACD? Okay, the first problem I see is that there's no diagram. So we're going to have to create the diagram. When it says they overlap, that's so irritating. So there's going to be 2 different ways we can do this. So we could have like triangle ABC. So let me write this. So actually wait, let me think about this before I do this. So we've got ABC and BCD. So that means they're sharing B and C. So to make this easier, I'm going to put B and C on the bottom and A on the top. You don't need to do it that way, but I think that's going to make it easier for me. And I'm actually going to draw, do I want to draw two now? I guess we'll just focus on one right now. So we know this is equilateral, 1, 2, 3. And then the question is, okay, BCD. Where's that going to go? It's overlapping, which means point D is either going to be inside or outside the triangle. So it could be there, or if I draw, let me draw ABC slightly smaller this time. ABC, that's the worst A ever. ABC, or D could be out there, like that. And it's our job to figure out which one makes sense. So we'll fill in our clues as we go. It says segment BD is congruent to CD, so BD and CD. Let's put this in both for now, BD and CD. And the measure of angle BDC is 110. Okay, so BDC is 110. This is going to be the step that tells us which diagram is going to be the actual diagram that's most closely to scale. And the reason is because we know in an equilateral triangle, now we're focusing on the equilateral triangles, all the angles must be 60. So if I get rid of them, we can add in 60 degrees right there and 60 degrees right there. Actually, on this one, we can add it in on all of them easily. Now, looking at this is going to be the diagram we want to go with. The reason is, let me do this in green so it shows out 60 degrees and 110 degrees. 110 is a bigger angle than 60, so it must be bigger, it must be more obtuse, or it's got to be obtuse compared to 60 being acute. And this 110 is smaller than this 60. So this diagram is not going to make any sense. We're going to use this one because that shows us, okay, 110 degrees, that's bigger than 60 degrees. So it made sense that way. This is the problem when they don't give us a diagram. We sort of have to, figure out all the possibilities and settle on the one that makes sense. And that's going to be this one. Okay, our diagram's finally done. What are they asking us to find? What's the measure of angle ACD? I'm going to target that in red. So ACD is that angle right there. So I'm going to highlight that. Just remember that's the angle we're focused on. All right. Oh, we're not even done with the equilateral triangle here. We put in one 60, this 60 degrees, but there's two other 60s. So this whole angle, that big angle is 60 degrees, and this big angle is 60 degrees. Oh, this diagram's going to get complicated. Tell you what, let me make this bigger so it's easier to follow. Let me group this. If it would let me work, let me group it. And then I'll expand it to make it bigger. Okay, I like this much better. So that's all we can do with the equilateral triangle, but we have not yet done anything with the isosceles triangle. If there's two congruent sides, we know there's two congruent angles. We just have to find the base. The base is the non-congruent side, So that is the base in this triangle, meaning this angle, how do I want to do this? I guess I'll do it like this. This angle and that angle are congruent. To find them, we know the three angles together add up to 180, so we can do 180. Take away the one angle they give us, 110, to get 70. And since the two angles we're looking for are equal, we can do 70 divided by 2 to give us 35. And 35, let's do this carefully in the diagram, goes there and it goes there. But this is really the one that I'm more focused on, that 35, because that's right next to the angle we're looking for. We know this big angle, this total angle, is 60 degrees. And we know this part is 35. So to find the missing part, we just subtract. We do, I guess I'll keep doing this in whatever color this is. We do 60, the total, minus the one part we know, 35, and that gives us 25, I think. So 25 should be the answer. Let's check it. 25 degrees. Excellent. Very good. All right, that's it. I hope this was helpful. Good luck studying for the test. Enjoy the rest of your day.